So I thought I'd play bingo with this talk. I've been at quite a few conferences recently, and the three things that come up in conference bingo at the moment are microservices, Docker, and Conway's law. So I thought I'd get it in straight away with a house at the back. Someone was shouting. Indeed, I thought I'd get it in straight away with a definition. So this is the definition of Conway's law. Organizations which design systems are constrained to produce designs which are copies of the communication structure of those organizations. So I think it was Eric Raymond who came up with another definition. If you ask 4 groups to write a compiler, you get a 4-pass compiler. Now, seeing as this is GOTO, this is a GOTO conference, and for example, we've got a keynote from NASA this evening, I thought I'd just quickly ask, is Melvin Conway actually in the room? That's quite good, because I could probably get into trouble for what I'm going to do next. So I've got this image in my head of Melvin Conway. I've never met him. I don't know what he looks like. But this is what I kind of think he looks like. Right? That's kind of sitting on the balcony laughing at us all, because back in 1968, he derived this empirical law, Conway's law. And it wasn't for quite a while before this was sort of taken seriously by either academics or, I guess, industry sources. So some years later, this is what the Harvard Business Review, in conjunction with MIT, said. It's a big wall of text. The important things are that tightly coupled organizations, even if not an explicit managerial choice, design naturally becomes more tightly coupled. So if you've got a tightly coupled organization, even if it's by accident, not by design, your systems will become tightly coupled. This is essentially the follow-on research that MIT and the Harvard Business Review did about Conway's law. In comparison, loosely coupled organizations, architecture that evolves is more modular. Now, I've been talking probably the last, 3, 4, 5 years about building modular building modular architectures. So this clearly is something that's kind of quite interesting to me, and it seems to fit quite nicely with microservices. And the rest of this talk is really us exploring why that might be. Some examples, they're real-world examples from my experiences, and there's another real-world example that isn't directly from my experience, which you'll see. But first, I think I should probably introduce myself. So I work for a company called Thoughtworks. This is the big spaghetti monster, which is kind of how I think of Thoughtworks. We've got tentacles everywhere. We're at a lot of the conferences. Rebecca Parsons, our CTO, is speaking afterwards. I work for Thoughtworks in the capacity of, I'm a software developer, I'm a software engineer, kind of a principal engineer, and I guess a kind of coding architect. So I spend 70% of my time on projects writing code. So hopefully I'm talking from experience, not because I'm a highly paid consultant, because I'm certainly not. Well, I'm a consultant. Let's put it that way. And I guess it was beginning of, not this year, last year, I sort of got together with Martin Fallon. We wrote a paper on microservices. If you haven't had a look at this, hint, hint, you can go to Martin's site and look it up. It's quite long, I warn you, about 8,000 words. It'll take a little while. But in that, we described the characteristics, as we saw them, of this new thing called microservices. And I want to be quite clear about that we were describing the characteristics rather than defining them. What we were doing was looking at lots of teams in lots of countries, both inside Thoughtworks and outside, lots of different organizations, and describing the things that we were seeing that were making them successful. So people like Netflix, people like Amazon, and people like The Guardian in the UK. Since there's been a lot more, so people like SoundCloud, Groupon, and so on. And we were trying to look at all the different characteristics that made them successful and describe them. Because the promise, I guess, is this, right? We should be able to build architectures that are cheap to replace, that are quick to scale, and that withstand failure. And to quote Adrian Cockcroft, we should be able, from former Netflix, these architectures should enable us to go as fast as possible in order to deliver customer value, business value to our customers. This is great. I use the word should in this deliberately. I say should because, and in fact, I'm going to give you a preview. Martin Fowler's about to release another paper on when you should and shouldn't maybe build microservices. Because there are quite a few people running into trouble with microservices architectures. And these are the sorts of things that I hear most, right, which causes most problems for people. The first thing is how on earth, if you've got this distributed system, how do you do end-to-end testing of this distributed system? You get into this kind of combinatorial problem, which I'll show in a minute, in terms of testing. The next thing is this idea of independent deployment. Right? How do you actually deploy all these individual things on their own? And if you can't do that, if you're having to deploy in lockstep, that's really going to limit your ability to get software out the door fast. And that's the aim, right? And then the last thing, the third thing, is service versioning and evolution. So this is how we maintain, how we manage services over a period of time. There's a rule of thumb that one of my colleagues in Australia, Evan Botcher, uses. He said these should be big, sorry, I'll rephrase. Microservices should be small enough that you can replace them within 2 weeks. That doesn't mean every time you want to make a change, you rewrite them again, right? So there has to be some discussion, there has to be some way of us evolving these things, maybe versioning these things over time. So these are the sort of top three. I've got testing in there. I don't know if Patrick Linsky's in the room. This is his major bugbear, so I put testing in. Hopefully he'll agree with me. But actually, the thing I most worry about is kind of related. It's not, though, explicitly testing, deployment, or versioning. The thing I most worry about, and the thing I see most organizations struggle with, is the impact of organizational design on their architectures, of organizational design on the way they're building their systems. And so I'm going to give you an example, I guess maybe to get us all onto the same page, and then I'll go through some case studies from other companies. So, a typical company, my colleague Ian Cartwright, he's got this great idea that there's only about 20 or so problems that organizations have. Not all of them have all 20. Most of them have between 5 and 12. Right? This is what organizationally companies often look like, big, especially IT firms, look like. So you've got functional silos testing, maybe some architects in there, ivory tower. You've got some development teams, you've got operations, project management office, and so on. And there's an interesting thing you can do, there's an interesting visualization of how these functional silos communicate. And this is using, you can draw something called a chord diagram, a chord visualization. So effectively what you do is you get this graph of how these different silos are communicating, and you can draw chords between the different silos, and you get this horrendous kind of ball of spaghetti kind of thing. Now this is fairly typical for a lot of processes in a lot of big companies. Right? So maybe requirements start with sales or marketing, they get passed over to the architects to design a solution. That's then passed over to development works on it, maybe passes it back to the architects, it didn't quite work out. They say, no, you're wrong, just do what we told you and it'll be fine. The developers say, no, it won't, et cetera, right? So this is the kind of process, the kind of flow that goes on. This is a real one. Again, it's there for illustration purposes, but you've got the roles down one side and all the different handoffs and things that happen across these different silos. And I kind of see it as a bit like this, right? It's a bit like sort of snakes and ladders. You'll start off with some requirements, it'll go into one particular group, maybe the architects. Hopefully, it'll go straight into development and then into testing, but most of the time, you're going to hit a snake and you're going to end up back at the bottom. And there's a great book, I should point out, contractually obliged practically, working for Thoughtworks, that talks in detail about this, called Lean Enterprise. It's fairly fairly new, Jez Humble's second. He's co-author along with Joanne Walensky and Barry O'Reilly, which talks very much, which explains how to maybe refactor your organizations away from this. Because why is this a problem? Why are all these communication pathways that go between these silos a problem? Well, essentially, each of these chords represents delay, right? Represents a delay in your process, in your ability to get work done as quickly as possible. There's a great quote from Peter Drucker: "There is nothing so useless as doing efficiently that which should not be done at all." And actually, this talk is about maybe how we can restructure this so that we don't have to do some of that work that perhaps shouldn't be done at all. So here's my first example. It's a case study. This is a real organization I spent some time with. Some time ago now, but it's still very valid. So they had development teams, and they were split between big project teams in London, big project teams in India. And when we say big, I mean fairly large. They were sort of 200 or so people in India, 100 or so people in London. So pretty big teams. And what they were building in these two locations were quite distinct. In India, they were building the sort of retail part of a system that they were creating. I should point out it was basically an e-commerce site selling tickets for things. Could be concerts, could be whatever. So they're building this retail site that's selling tickets, essentially. And over in London, you've got fulfillment, right? Where fulfillment is the ability to get those tickets to people, communicating with lots of other organizations, lots of integration points in order to do that. So they had these two very distinct kind of capabilities. And quite nicely, in this case, right, they had this big bus in the middle. Now, being from Thoughtworks, I'm not a huge fan. It's canon to rail against enterprise service buses. They had a message bus in the middle. And essentially how these two groups of developers, how these two systems they created, communicated was by passing big messages across between them. So when there'd been a sale, a message would go off onto the bus and would be pulled off on the other side by fulfillment, and then fulfillment would happen. So tickets would be sent out, invoices would be done, etc. Which is all good. We've got this kind of nice decoupling between the two sides of this system, right? So thumbs up. I mentioned the word capability. So a capability, I'm going to define, is a combination of people, processes, and systems that provides value to customers, internal or external. It's the what of what your business does, not the how. So it's the what. What does your business do? Well, it fulfills stuff. It sells things. Maybe it prices things, these sorts of things. And in this case, they had these two capabilities separated by this bus, and on either side of this bus, they had these giant teams, right? 200 or so, 100 or so. And the way they managed these teams was according to the kind of traditional functional silo kind of model. So they had developers, testers, project management office. So these bigger teams were separated out into short-lived project teams. So they'd get a group of developers who'd come together to fulfill some requirements, and then they'd move on. And they'd sort of wander around the code base, touching parts of the code base, kind of all over the place until they got back to normal. And all of these different projects were going on all at the same time, all crawling over different parts of these code bases on both sides. And what ended up happening some years into development, so it was a greenfield initially, and then maybe 3-4 years later, is they had this really tightly coupled system either side of the message bus. So they'd ended up building some web services. It was a .NET stack. And they had these really, really, really tightly coupled services. They were kind of early bound, and I'll come on to some of the other facts in a minute. And this is right? This is Conway appearing and just laughing at them a little bit. Because what's happening is with these short-lived teams, right, there's no actual sort of ownership of any of these services that they were building. And over time, as developers were touching one bit of code and another bit of code, these things were bleeding together and naturally becoming kind of one system, even though it was a distributed system. They were also using Scrumiful, essentially, as a method for delivery. So they were running in iterations, and then maybe they'd have 6 weeks, 3 2-week iterations, and then they'd have 6 weeks of testing of different types. And because these things were really tightly coupled, because these services were really tightly coupled, they all needed to be tested together, right? So end-to-end testing basically happened after 3 iterations, and there was this huge fan-in of services where they'd run lots of end-to-end tests and regression tests. And they'd also have to be deployed together. So there'd be 6 weeks, and then 6 weeks of testing, and then boom, the whole thing would go out. And this is what we've sort of come to know as a distributed monolith. People have heard that before. I mean, the whole point of building these systems composed of microservices is that these things should be decoupled. You should be able to test them and deploy them independently. And this is not really as fast as possible. This is effectively a recipe for a nervous breakdown. And in fact, their developers and architects and ops people spent most of the time stressing about these things. So that's maybe an example of some good stuff. So some capability, they've split into capabilities. Conway law is acting, so they've got these messages passing between these capabilities. But within the capabilities, because they were using a particular organizational design, functional silos, they were using Scrumiful, they ended up with this really tightly coupled big ball of mud, essentially. So what might good look like? As I say, most of these examples are from my personal experience. This next one isn't. I don't know if anyone recognizes this in the room. Can I hand up if anyone recognizes that? Yeah, one person. Would you like to shout out? Because we can all laugh at you if you get it wrong, then. Nearly. It's a virus. It's actually the Ebola virus. It's a electron microscope image of the Ebola virus. This is the bit that didn't happen to me. I've never caught Ebola, fortunately. But this woman did. She was a nurse who was seconded to the British Armed Forces and was in Africa when the international response was mobilized. Her name is Pauline Kafiki, and she was flown home back to the UK, back to London, and she was treated at the Royal Free Hospital, which is, I guess, in London, it's actually the UK's specialist hospital for infectious diseases. And this is the team that treated her. This is from a newspaper, the Evening Standard in London, who ran a story about this team. It's quite a lot of them. There's about 33, I think, of them or so. Fortunately, she survived. In fact, they treated 3 Ebola patients at the Royal Free. They had a 100% success rate. Extremely, obviously, fortunate for those 3 individuals. But it really struck me as kind of what is it about this hospital that's causing this? Because if you think about hospital, and we go back to the definition of capabilities, I mean, hospitals have lots of these different capabilities, right? They have like facilities, they have lab services, they have things like physio, they have pharmacies, all these different capabilities. And again, if you plot that on kind of a chord diagram, you'd think you'd get all this tremendously wasteful communication overhead as these capabilities, the clinical staff are communicating with the porters and communicating with the pharmacy and so on. And that's not ideal in the world of clinical care. This is something called the OODA loop. Mike Nygaard has talked quite a lot about this in his talk on building maneuverable architectures. So the OODA loop was invented by a US aviator, military aviator. His name was Colonel John Boyd. And he came up with this idea as a mechanism for training pilots. And it was adopted by the US Air Force. It was adopted by the US Army. In fact, it's pretty much taken as a given that this is how you go about deciding on the best course of action. And not only that, because of where it came from, kind of, I guess, overwhelming your, quote, enemy. So he was a fighter pilot. His idea was, in order to be a successful fighter pilot, to be successful in dogfights, you went through this decision-making process observe, orient, decide, and act. And the idea is that you want to be able to go through this process faster than your enemy, in the case of a fighter pilot. But this is broadly applicable to organizations at different levels, to teams, to departments, and to organizations in general. And there's a great quote, which is, "This approach favors agility over raw power." It's all about agility. And you can see there's feedback loops in it. So the idea is you continually execute this OODA loop, the observe, orient, decide, act. And in the case of clinical care, right, where people are desperately, desperately sick, they need to, those doctors, those physicians need to be going around this OODA loop super, super fast. And they need to remove all the overhead associated with delay. So this, and again, you won't be able to see this, but this is the team. There's a lot of them. The interesting thing about the team that was caring for them, the ones in bold are the clinicians. There's about 12 clinicians involved out of 33 or so, compared with about 21, or exactly 21, non-clinicians. So these are people from other capabilities, right? So pharmacy, physio, facilities, finance is up here, right? The porters are up here. And this is a quote from the guy who was leading the infectious diseases unit at the time. He's Dr. Michael Jacobs. He's a consultant. If you imagine all the functions a hospital has to have, not only the doctors and nurses, etc., they all have to be involved. And so this is what the hospital does in the case of infectious disease, where they really need to get around this decision-making loop as quickly as possible. They've got all these different capabilities. Actually, what they do is they bring these disparate capabilities together. They have representatives from each department, each capability in one place. So they have physiotherapists, they have pharmacists, and so on. Essentially, what they do is they create these cross-functional teams. We're familiar with that from software development. They have a single purpose, and they're focused entirely on, in their case, patient outcomes. And it's about organizational design. Why is this important? Well, this is from a study we did that was done in Australia on one of our projects. This is about the length of time it takes to get requirements into production, if they have to cross team boundaries or not, right? So this is the cords going between different teams in a functional silo, or crossing service boundaries, essentially. And it says that cards that leave the team, they have a wait time of 8 days, and they cycle in 23 days. Whereas if you can do all your work within a team, the wait time essentially is 0, and the cycle time is about 2 days, which is vastly superior. And this is why the clinicians want to be all in one place, in one capability, with infectious diseases. Essentially, it's a line of business within the hospital. I mean, this is not only true for hospitals, right? This is true for things like for infectious disease. Trauma teams do the same thing. So my sister's a trauma nurse, and what happens, when a trauma case comes in, is they kind of swarm. So they get people from lots of different departments all in one place. This is true for Formula One teams. So this is racing. This is racing. All the team is completely cross-functional. The drivers are a part of it. Yes, they drive on the day, but actually during race day, during testing, it's a completely cross-functional team. And actually from the military, this idea of reinforced battle groups, which came from partly from Colonel John Boyd, is also based on this idea of kind of cross-functional lines of business. Well, I have another one. This is a software existence proof. So going back to our general, siloed organization. This is an example of an organization, of a company I was at for another, I don't know when this was, so probably 5 years ago I started, and I haven't been there for about a year and a half. But what they ended up doing was replacing the kind of architects, project management office, and so on with cross-functional teams organized around these lines of business, right? Like the infectious diseases unit in the Royal Free. It was an insurance company, and they actually started off with a monolith. So they started off with it's a .NET project, so they had big web app, they had a big database, lots of stored procedures. And they wanted to refactor this towards something that was a bit more decoupled, and they did that partly by reorganizing their teams around lines of business. They wanted to extract parts of the application out. And what they ended up doing is extracting the bits out that were the lines of business, as I say. So the home insurance bit came out, and the pet insurance bit, the motor insurance bit, all into separate capabilities, separate lines of business, rather. So we ended up looking like this. We had home, motor, and life, and then they had some cross-cutting stuff, right? So they had things like My Account, they had like data warehouse, these kind of things that were kind of cross-cutting groups across these lines of business. And they organized these teams, cross-functional teams, around the lines of business. And Conway's law kind of reinforced, back to Conway's law, reinforced these team boundaries to provide kind of decoupling between them. Much more difficult to couple these capabilities together when you've got long-lived teams around. So this is one thing we can do in order to help take advantage of the idea that our architecture will look like our organizational design. We can make our organizational design look like the architecture we want. And then naturally over time, our architecture will evolve to it. So this is all good. All right, big thumbs up. But we still have a lot of these chords on here. We still have a lot of communication pathways, a lot of work that's going outside of these lines of business out to other parts of the organization. So in this case, we've got lots of lines between things like the lines of business teams and operations. They had a separate operations group, and also to things like sales and marketing. And again, we've got Mr. Conway kind of right. This is another example of Conway's law, of Mr. Conway laughing at us. Then they played something that's pretty cool, I thought. They played the Jez Humble card, bang, right? In order to kind of, again, minimize the overhead of handing work off between teams. And they went, yay, DevOps, hooray. Anyone got that on the bingo card? All good. Notice, 3 exclamation marks with DevOps. I had a great quote once, which is, any use of more than one exclamation mark is a sure result of a deranged and damaged mind. That's me. Well, it wasn't really DevOps they implemented. They implemented kind of continuous delivery. So they pulled the operations team into their lines of business teams. That was the first thing they did. So they ended up sort of looking sort of a bit more like this. These lines of business teams were a little bit bigger, but suddenly the communication pathways between these teams disappear. So they're making their process much more effective. They're reducing lots and lots of waste as they go. Big thumbs up. And the nice thing about this, right, we were talking earlier about testing independently. We were talking about being able to deploy independently. Because of the way they were organized like this, they were able to do all these things. They were able to deploy independently. They were able to test independently. These applications were completely decoupled from one another. Which is great, but can we actually take this one step further? Because we've still got some of these lines. And actually, yes, there are a lot of existence proofs that exist of companies that take this another step further, right? So we don't just have these cross-functional teams with maybe product owners and developers and testers and QAs, and analysts in one team, organized in a particular way. They actually bring in more of the business, so bring in sales and marketing and potentially finance into these teams as well. The idea being that we want to be able to make all decisions, or maybe 99% of decisions about the work we're doing within a small group, trying to completely avoid this handoff of work across between different departments, right? Aiming to really streamline the way we get work done, reducing waste and minimizing cycle time. So I mentioned this phrase, lines of business. This is an example of one organization in Australia that's gone down this route. They have they have distinct lines of business, and these are completely cross-functional across the business as well. So they have everything they need within that team. They have sales support, they have marketing support within that team. And this is this kind of defined outer ring of sort of line of business. It might be a kind of infectious diseases in the case of a hospital. Within that, they decompose the whole line of business into potentially different value streams. So if they've got their own analytics, they'll say, okay, we'll have a different value stream for analytics. We'll have one in each of our lines of business. And yes, there's maybe some duplication across them. There might be multiple analytics teams, value streams, essentially. But what they gain is this massive increase in throughput and reduction in cycle time because they're not having to hand off work to another department, which takes lots of time. And then they decompose that further into teams. And in that case, each team owns one or more services. There are other examples of this. The folk at Netflix, some people are here from Netflix, but the folk at Netflix are on the record about how they organize, and it's very, very similar. Each team will own one or more services. They have some guidelines as well for size, say. Team size is around 10 to 20, so the individual teams are made up of almost like XP-sized teams, so between 10 and 20 people. And they'll have multiple of these teams within a value stream, say, depending on how big it is. But they try and keep those value streams down to about 160 to 200 people. And this is an interesting number, 160 to 200. So 160 was the original, was Dunbar's number, about 165, I think it was. So this is the number of connections, social connections that we can hold in our heads at any one particular point. Right, apparently. And there's been further research done since he did the original research, and I think that's maybe increased the number a little to, I think it was around 200. So what we're saying is we want to keep the sort of the sort of groupings of people to about 160 to 200 people. And then as you grow up, you want to proceed in multiples of that. There's another interesting bit of research I was doing. It's from this book, Managing the Flow of Technology. This was first printed in 1977, and this was reprinted, I think, 1984, 1986, something like that. It's some bits are out of date now, but it's also got some interesting research relevant to this idea of small teams co-located, cross-functional. Because what it says, in this, I'm reproducing this, took me ages to make this graph. I could have taken a photo, but I thought this was nicer. What it says is that so in the book there is a lot of they do a lot of research about different research and development departments and how people working within the research and development department interact with each other over time. And what they found about work, so they're talking about work rather than just shooting the breeze. And what they found was there's a direct effect. There's a huge effect that distance has on the amount of communication people have. So this is the actual results. And what they found is this is along the bottom, the scale is out 0 to 100 meters. And on the y-axis, we've got the probability of weekly interaction. And they found that very quickly, if you fit the curve, weekly interaction decreases asymptotically to 0, essentially. And in fact, at 20-odd meters, if you're 20-odd meters away from someone, you're really vanishingly unlikely to have weekly interaction with them. Now, this is really important. You think back to things like the hospital. You think back to our ability to interact together as groups, getting software out the door. Having serendipitous conversations with each other, overhearing our colleagues say, I was just hacking on that particular piece of code, and it's a bit messy, isn't it? And then someone being able to say, oh, yeah, I kind of wrote that. It's like that for a reason. Distance is really important the distance apart people are is really important. There's a really important factor in how often we have that sort of serendipitous conversation. So, the idea is that what we should do is co-locate as much as possible. We should sit people who are doing the same things in terms of this line of business, or the teams of the services together as much as we possibly can. Obviously, these days we've got things like HipChat and Slack and all these, and video conferencing and all these different mechanisms for improving the amount of communication we have. But the serendipitous conversations, the ones you just sort of overhear by accident, you won't have even on those things. So, fine, how does this help with testing, deployment, versioning, and so on? What I've basically been saying is that we want to organize we want to structure the organizational design. We want to have an organizational design that's around lines of business, value streams, and then small teams. How does that impact on testing and deployment of microservices? It's a good question. So I'd like to introduce you to something I've been thinking about recently called the microservice stability onion, which is directly related to these sort of organizational structures, these nested organizational structures. Because one of the, I'll move back one. I mentioned earlier that we've got things like testing, we've got deployment, and testing often becomes really, really difficult. Deployment often becomes a kind of lockstep procedure. Now, there are a number of things that people often sort of talk about with microservices and say, oh yes, but that's a solved problem because you can do things like use semantic versioning, consumer-driven contracts. We can do all these things. We can use, I don't know, all these, semantic versioning, consumer-driven contracts. I'll have a look down here. Things like tolerant readers, the pattern, to manage the complexity of decoupling services from one another, which is fine. But implementing things like consumer-driven contracts, implementing semantic versioning, actually costs money, right? You actually have to expend effort to do these things. And like anything, right, we want to expend effort at the point where it's going to be most valuable, and we don't want to expend that effort at the point where we're not going to get any value from it. So the microservice stability onion uses this, or kind of is related to this concept of how teams are structured, how organizations are designed, to kind of help make some of those decisions. Because at the sort of boundary of a line of business, where we're either talking outside our organization or we're talking between big chunks of our organization, we want to sort of optimize to maximum stability, essentially. Right? I mean, if you're building the Google Map API, you don't want to be changing that very frequently. So at that point, you definitely want to be thinking about having stuff like semantic versioning. So semantic versioning being, very stable versioning. Semantic versioning being where you have a structure that everyone agrees that you're going to use, where major, so you have major, minor point versions. Major versions a major version bump indicates a backwards incompatible change, whereas minor and patch indicate backwards compatible changes. These sorts of things you definitely want to expend effort in implementing at the boundary of your organization. But would you necessarily want to do that internally as you sort of shrink, as you get into more layers of the onion? So what about between different value streams? Right? Would you want to implement semantic versioning then? Quite possibly, because even though the rate of change is probably slower, there's still going to be some churn. But also you might want to spend the time implementing, for example, contract testing. There's tools now, so there's one called Pact, there's another one called Pacto, which is a bit of a nightmare in terms of the fact that they're called the same thing essentially. But you can, which allow you to quite easily implement contract-based testing. So you can implement consumer-driven contracts. And at this point, it's probably worth actually starting to do that, implementing consumer-driven contracts. Also at this point, because each side of these arrows you've got control over the kind of client and producers, you might want to think about mandating things like tolerant reader, so late binding to requests, to responses. And what about inter-team? So between teams within a value stream, where again, the rate of change is going to be higher the closer you get. So at that point, you might maybe be thinking about contract testing. You might be definitely thinking about things like tolerant reader. And then intra-team, you're talking about tolerant reader, and we're talking about things like conversational change. So this is, I made that up because it was a conversation I had with Adrian Cockcroft where he basically said his experience at Netflix was that API changes within a team versus outside a team, or that impacted outside a team, had a ratio of about, I think it was 10 to 1. So 10 changes internally versus 1 change that crossed team boundaries. So that kind of conversational change, if people are sitting together, if people can have serendipitous conversations, maybe you don't need so much ceremony around change. Maybe you don't need so much ceremony around things like versioning. So I'm coming up to the end. Some thoughts to finish. This is this idea, essentially, I've been talking about, which is the inverse Conway maneuver, described by my colleague Evan Botcher as design the organization you want, the architecture will follow, possibly kicking and screaming. You can watch out for signals from Conway's law. Things like, if you're constantly having to order work across different capabilities, you've got portfolio management becomes a nightmare. If you're constantly having to split stories that cross team boundaries, that's maybe another signal. If you're having to move people around to follow where the work is, another signal. Certainly deploying in lockstep, and definitely this idea where you fan in, have to end-to-end test, fan in lots of different services and test them all at once. And as I say, to restate, it becomes much easier to test and deploy independently with Conway's law helping. So I started this with the thing I most worry about is not versioning, deployment, or testing. It's actually organizational design. And that's why I finally learned to stop worrying and love Conway's law. Thank you very much.